Okay, now the purposes of this video is to explain the transformations of functions. This video is one of 3 where I'll go through the 7 key transformations of functions that you would need to be aware of. So in this first video, the main learning objectives are to be able to solve problems that would involve the transformations y equals f of x add a and y equals f of x add a. Now they are slightly different, and the idea is to look at the impact that each of these would have on a graph. And if we can explain those effects, then we'll be part way to be able to solve any of the kinds of problems that we could have. So the first key concept I'm going to go through is going to be about y equals f of x add a, where it's outside of the function or after the function. And this add a could be minus a as well. Now the best way to demonstrate this is using a little bit of a video clip where I have a function of x squared, and the slider on the right where it's got a equals 0 at the minute means that we just have our function, we're not adding or subtracting anything, so we're not going to see any changes yet. But if we was to go through and just play this video a little bit, and as the slider moves to the right, you'll notice that the graph does change and it moves in a vertical direction. It's moving upwards in this case. And pausing the video just there, where a is at 3, that graph has moved 3 units or 3 places up the y-axis. So if a is positive and we're adding a positive value, that is how our graph transforms. If I carry on the video now, where a is again changed, you can see that as it's getting smaller, it heads towards 0, and then eventually when it's negative, you'll see that the graph is dropping below the x-axis, or it's becoming negative now. So any value of a, whether it's positive or negative, affects the graph vertically. It doesn't shift the graph left or right at all. So in a coordinate, the x-coordinate is always going to stay the same, and it's only the y-coordinate that's affected by anything that happens. Now this type of transformation is a translation, which you may be familiar with shapes, and the best way to describe this is in a vector. So we've got 0 at the top because the graph didn't move left or right along the x-axis, but a at the bottom would indicate how many places the graph has moved vertically. Now the second key concept that I'm going to go through is to do with what happens if we've got a function of x add a, where the x add a takes place prior to the function kicking in. And so to describe this or demonstrate it, I've got another video where the slider of a is set to 0 so that we do have f of x on the screen, or our function, and then as we move the slider we will see the impact that it has on the function. So to start off with, I'm going to move it so that a is a positive value, and as the slider goes to the right, what you will notice and you'll see will happen is that the graph has actually moved to the left. It runs in the opposite direction to what you would actually think. So as the slider goes further to the right and a becomes more positive, the graph has translated to the left, that same number of places. Now this is against what most people would naturally think, that naturally you would believe that adding a value would move the graph to the right, but we have to understand that the impact is opposite. The best way I found of explaining it is that if we wanted a function where x was 0 and that y was 0, so that was true, then if we've got x add 5, as we might have here, then in order to get that back to 0, x would have to be negative 5. And it's a sort of compensation that we need to have in place. Now if I carry on the video again, it will demonstrate what happens as we make a positive value. So as it goes there, we can see that when a is at negative 3, the graph has translated 3 places right. And so the graph is shifting left and right as a result of this value of a being added or subtracted inside the brackets, but in the opposite direction to our natural thinking. So if you were describing this, it would be a translation, that's what's taken place, and the vector this time would be negative a over 0, where it's negative a because it's the opposite to what would happen. So if it did say minus 2, then the translation would be 2 over 0, and similarly the other way around. Now what I'm going to go through next is a Gcse style question, where what we've got here is a function sketch at the top, so it's not an accurate diagram, we can't do anything with it. We don't know the function either, but we are told the coordinates of the minimum point of the curve, and it could be the coordinates of any point on this curve, but typically they'll choose some key point. And you're asked to write down the coordinates of the curve within a different equation where the function has been changed. And these two examples here are like the examples that I was going through earlier and describing. So in going through the solutions in part A, we've got this function of x add 3. So that add 3 is going to impact only on the y coordinate. So if we take the original coordinate, we're only going to add 3 to the y coordinate because the graph shifts vertically, it does not shift horizontally, so the x value does not change, giving us our answer of 3, 4. In part B, it's inside the bracket, so it takes place before the function, and if you can recall, it's going to be the inverse. So because it says subtract 2, we're going to do add 2. And because it's taking place before the function, that means it's going to impact on the x coordinate. So the x coordinate will add 2 to, and it will become 5, 1. There are other examples like this that you can find if you just do like a Google search, but this is the kind of impact that you will need to do. Other questions in exams have focused on you sketching a graph after these transformations, and so you'd have to think about how it would change things. That's it for the first video. The second video is going to go on to look at what happens when we're multiplying by a value of a in 2 different places and the impact that that would have on the curves. I hope this has been helpful. Please leave any feedback that you'd like to below. Thank you.